Hello children, and welcome to the Day 1 Reactions homework tutorial video. This first worksheet for the Law of Conservation of Mass, Law of Conservation of Mass is really easy. It basically says that whatever reactants you start with, you have to end with the same thing. So if I start out with 42 grams of a reactant and it goes through some kind of magnificent chemical reaction, I have to end with 42 grams of product. It doesn't matter what we do. It doesn't matter what happens. So for number 3 here, I have 50 grams of calcium, and I'm going to add that to 150 grams of zinc carbonate. Well, together, my reactants equal 200 grams. Okay, my products on the right-hand side of the arrow, I have 125, it makes 125 grams of calcium carbonate. And how much zinc is left over? Well, if I have 200 over here, that means that together has to equal 200. Okay? So I go 200 grams of reactant minus the 125 grams of calcium carbonate. That gives me 75 grams left over. Well, that must be my zinc. Okay, 75 grams. What you start with, you have to end with. So the products have to equal 200 grams. Okay, number 5, calculate the mass of zinc that reacts with 4.11 grams of hydrochloric acid to form 9.1 grams of zinc chloride and 3.97 grams of hydrogen gas. Well, mass of zinc that reacts with hydrochloric acid. So that means I have a certain amount of zinc plus 4.11 grams of hydrochloric acid. And it says it forms. Okay, that means that something happened. A chemical reaction has occurred. That means it yielded 9.1 grams of zinc chloride and 3.97 grams of hydrogen gas. So in order to do that, I'm going to first add up my products, see what I've got. So 9.1 plus 3.97 gives me 13.07 grams of product. So I got 13.07 over here. That means I have to have 13.07 here. So I go 13.07 minus 4.11, and that gives me my product, or the rest of my reactant. Sorry, the rest of my reactant. 8.96 grams. That and that, they all have to be equal in mass. Okay, so that equals 13.07 grams. That equals 13.07 grams. That's the law of conservation of mass. Okay, page 2. Okay, doing some reactions here. All right, we've given you products. These are all synthesis reactions. So when you have a synthesis reaction, 2 single reactants will combine to form a product. So for number 2, I have calcium plus fluorine. So what can that make? Well, the only thing there is to use in this reaction is calcium and fluorine. So that's going to necessarily, there's no other way about it, it's going to make calcium fluoride. So when it makes that new compound, I have to do the same thing I did before. I have to check oxidation numbers. Calcium's in group 2, so its oxidation number is always +2. Fluorine's oxidation number is always -1. I crisscross and use them as subscripts. So that's a 2, that's a 1. And then I have to balance it. So I'll have Ca, I'm copying over from here, calcium plus diatomic fluorine yields calcium fluoride. Okay? 1 calcium in the reactant, 1 in the product. 2 fluorines in the reactant, 2 in the product. So check. That is balanced. Alright, so next one. Sodium plus iodine. Well, sodium plus iodine is going to make some sodium iodide. Sodium's oxidation number, it's in group 1, so it's always +1. Iodine is a halogen, it's group 7, so it has an oxidation number of -1. So when I crisscross those, I'm going to get 1 and 1. Okay, so to balance it, I'm going to copy over what I have here. Sodium plus diatomic iodine yields sodium iodide. Okay, that iodine has a 2 because it's diatomic. It can't be by itself. Okay, and when it is by itself, it has to get a subscript of 2. Over here, it does not get a subscript of 2. It is not by itself. It's bonded to sodium. We checked oxidation numbers. That's how we got the subscript of 1 and 1 there. Okay, now you need to balance the equation. 1 sodium, 1 sodium. 2 iodines, 1 iodine. All I can use to balance is a coefficient. So I'm going to put a coefficient of 2 there. That coefficient of 2 gets distributed to both the sodium and the iodine, giving me 2 iodines on each side. Well, now I have 2 sodiums in the product, so I go over here and I put a 2, and then it's balanced. All right, decomposition reactions. You know it's a decomposition reaction because you start out with one single reactant and it breaks down into its parts, into its pieces. Water is made of hydrogen and oxygen. Okay, but remember, they're part of the Brinkelhoff gang, the group of atoms that can't be alone. So bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. Okay, there you go. All of those are diatomic. So when you see them by themselves, you get to give them a subscript of 2. Okay, so we're going to balance the equation over here. So I'll recopy it. H2O yields H2 plus O2. So I have 2 hydrogens in my reactant and 2 in my product, but 1 oxygen in the reactant, 2 in the product. So I'll need to balance that, and the only thing I'm allowed to use is coefficient. So I use a coefficient of 2 to give me 2 oxygens. Well, that threw off the hydrogens, but that's okay. 2 times 2 is 4. And if I use a coefficient of 2 here, I'll have 4 hydrogens. And then it will be balanced. So aluminum chloride will break down into aluminum plus chlorine. Remember, chlorine's one of the diatomics, so when it's here by itself, it gets a subscript of 2. Now I can balance the equation. I put AlCl3 yields Al plus diatomic chlorine. Okay, the aluminums are balanced on either side of the equation, but the chlorines aren't. All right, they both have to be equal. All right, so I have 2 here and 3 here. Well, the only thing I'm going to be able to do is even this up. This is never going to work out when we have an odd number. So I use the smallest coefficient I can to get it to even up. So if I use a coefficient of 2, that would give me 6 chlorines. I put a 3 here, that gives me 6 chlorines. 2 aluminums here, use a coefficient of 2, 2 aluminums. Okay, all done. That equation's balanced. So let's look at this combustion reaction. Combustion reactions can be difficult. All right, not gonna lie, they can be hard. So one way to do it, what I tell my kids is I always double the first carbon. So I'm going to write it down here so I have a little bit more room. C2H4 plus, what are the pieces of a combustion reaction? Well, they're always the same. You'll have some sort of hydrocarbon here plus oxygen, because you need oxygen for it to burn. It's always going to yield the same 2 products. It's going to always yield CO2 and H2O. So I know how to complete that all the time, these hydrocarbon combustions. We give you a hydrocarbon, and you combine that with oxygen in the reactant, and that will always yield carbon dioxide and water. So now we need to balance. Well, I tell my kids always balance by doubling the first carbon. That means put a coefficient of 2 in front of the first carbon. So, and I start balancing everything based on that. So 2 times 2 gives me how many carbons? 4. So I put a 4 here. 2 times 4 gives me 8 hydrogens. So I go back here. 4 times 2 will give me 8 hydrogens. I count up all the oxygens in my product. I have, that's 8 plus 4 times 0 is 4. Was that 12? Okay. 6 times 2 is 12. So this is all balanced. Okay. When you have coefficients that have to be reduced, all of these can be divided by 2. You go ahead and do that. So that is going to be a 1, 3, 2, 2. Okay? So my balanced equation will be C2H4 plus 3 oxygens yields 2 carbon dioxides plus 2 waters. And it's balanced. Okay? So page 3. Okay, I tried to pick out some that might be a little harder for you. So what type of reaction is this? You have 2 single reactants and a compound for a product. What is that? that's a synthesis reaction. Okay, I need to balance this. This looks scary, but it's probably not. I have 8 sulfurs. Well, let's just put an 8 here, see what happens. 8 sulfurs, 8 sulfurs. 2 oxygens. How many oxygens is that? 8 times 3 is what? 24. So if I put a 12 there, that equation's balanced. 8 sulfur, 8 sulfur. 24 oxygens. 8 times 3, 24 oxygens. Bam, it's balanced. Alrighty, so let's see. Let's do this one. This is, it looks like a difficult reaction, but it's really not. It's just longer than the one we did, so it's fine. Okay, this is not a combustion reaction because there's no oxygen here, and your products are not carbon dioxide and water. So that is not a combustion reaction. What do you think? This is called a single replacement reaction. And we'll do single replacement reactions next time. We'll tell you how to identify them. But right now, all we're going to do is balance. Okay, 10 carbons. Let's just go ahead, just jump off. 10 carbons. 16 hydrogens. Oh, don't be afraid. Don't be afraid of big numbers. 16 hydrogens. 16 chlorines. How do you make this 16? 8. So, coefficients 1, 8, 10, 16. And no, you cannot reduce these. Why? Because they would all have to be divided by the same number. I can't divide that by 2 and still have a whole number, so that's a definite no. Alright, that's your balanced equation. So let's go over here. What type of reaction? This is called a double replacement reaction. Another one that we'll learn about next time, but all we're doing is balancing in this video. So let's see. Ooh, it looks messy. It's all messy over here. When you have hydrogens, like when you have the same element on the same side, both of these are in the product, they add together. So that would be 4 plus 1. That's 5 hydrogens in the product. Okay? You have to add the hydrogens together if they're on the same side. So let's see. 1 silicon, 1 silicon. I'm good. 4 chlorines. Let's go ahead and put a 4 here. See what happens. 4 chlorines. How many hydrogens? Well, let's see. I have 4 here and 4. So that's 8 hydrogens in my product. I'm going to put a coefficient of 4 there. 4 times 2 gives me 8 hydrogens. So let's check the oxygens. There are 4 oxygens, and looky there. 4 times 1, 4 oxygens. So the 1, 1, 1, 4, 1, 4, and it is balanced. Okay, number 11. What type of reaction? This one's a single replacement, and let's go ahead and balance it. So I have 1 aluminum and 2 aluminums. The only thing I can use to balance these equations are coefficients. So I put a coefficient of 2 right there to make my aluminums equal. Then I go on to iron. Look, iron, 1 iron, 1 iron. Good. But my oxygens are off. So I have 3 oxygens in the product. So I give 3 oxygens in the reactant. Well, that made me have 3 irons over here and 1 here. You just add a coefficient of 3. 2, 3, 1, 3, and that equation is balanced. Now remember, all you're doing on this video is balancing equations. Don't worry so much if you can't identify all the reaction types. Identify the ones that you think are correct. The rest of them we'll work on. But do all the balancing on here. It's very important. Just go back and forth until you have the same number and type of each atom on each side of the equation. Good luck, guys.